Good morning, grade 9 students, and welcome to another new lesson. Today, we will study about the third law of motion, also known as the law of interaction. For our intention, competency, explain that when any two objects interact, there are equal but opposite forces exerted between them, which is evident in many practical situations and applications. Objectives. At the end of the lesson, the learners should be able to first, define Newton's third law of motion or law of interaction. Second, identify action-reaction force pairs in different situations. Lastly, demonstrate appreciation of the importance of balanced interactions in motion. Think about it. Look at the man wearing roller shoes. If the man pushed this wall as hard as he can, will the wall push him back? He pushed the wall forward, but he moved backward. Did the wall just push him? Surprisingly, the answer is yes, it did. And it's not because the wall is alive. It's because of the third rule of motion, the law of interaction. Sir Isaac Newton noticed something about forces. Forces never happen alone. They are like shoes. They always come in pairs. For our learning experience, we will have a simple activity, and it's titled The Balloon Racket. The materials that we will use are the following: balloon, a drinking straw, a long piece of string, and tape. First, thread the string through the straw and tie the string across the room. Then, blow up the balloon but don't tie it, holding the neck shut. Tape the balloon to the straw. The nozzle points backward. Then, release the balloon, then observe its motion. For our guide question, number 1. Which way does the air go? Second, which way does the balloon go? It's time to check your answer. Number 1, whoosh, the air shoots backward. And second, the balloon rockets forward along the string. So the air and the balloon have opposite direction. For more guide questions, number 1, what was the action force in this experiment? Second, what was the reaction force? And third, did they move in the same direction or opposite direction? Let's check your answer. Number 1, the action force was the balloon pushing the air backward. Second, the reaction was the air pushing the balloon forward. Number 3, opposite directions. Air went back, balloon went forward. So from our activity, the action is the balloon pushes the air backward, and the reaction, the air pushes the balloon forward. From the activity, we learned about the Newton's third law of motion, which states that for every action, there is an equal and opposite reaction. This means whenever object A pushes object B pushes back with the same amount of force but in opposite direction. These forces act on two different objects. That is why he moved back when he pushed the wall. The action is he pushed the wall, and the reaction is the wall pushed him back. To truly understand about the law of interaction, let's look at the characteristics of interaction. To truly understand this law, remember the 3 rules of pair. Rule number 1, equal magnitude. If you high-five your friend with a force of 50 newtons, their hand hits yours back with exactly 50 newtons. That's why it hurts both of you. Rule number 2, opposite direction. If you push down, the reaction pushes up. If you push left, the reaction pushes right. So it's always opposite. Rule number 3. Different objects. The action force acts on object A, and the reaction force acts on object B. They do not cancel each other out because they hit different things. And now for application, let's look at examples of action-reaction in our surroundings. For example, when you walk, the action is the foot pushes the ground backward, and the reaction is the ground pushes foot forward. Another example is when you swim. The action is the hand pushes the water backward, and the reaction is the water pushes swimmer forward. Another example is flying of birds. The action is the wings pushes the air downward, and the reaction is the air pushes the bird up. This time it's your turn. Identify the action and reaction forces on the following images. First, the book on the table. What is the action and the reaction? Second, a boy kicking a soccer ball. Third, a racket. It's time to check your works. First, the book on the table. The action is the book pushes the table downward. And for the reaction, the table pushes the book upward. For the boy kicking the soccer ball, the action is your foot pushes the ball forward. And for the reaction, the ball pushes your foot backward. And for the racket, the action is the racket pushes gases downward. And the reaction is the gases push the racket upward. And now it's time to wrap up the Newton's third law of motion. Number 1. Forces always come in pairs, action and reaction. Number 2. The forces are equal in magnitude but opposite in direction. Number 3. Crucially, these forces act on two different objects. Number 4. We cannot move without this law. Walking, rowing, and flying all depend on pushing something back to go forward. And now for our ways forward. Observe at home 3 situations where Newton's third law can be seen. Accomplish this form. Situation observed at home. Identify the action force and the reaction force. And now, get your notebooks and your pen. It's time to assess what you learned from our lesson. Number 1, Newton's third law states that for every action, there's an equal and blank reaction. A. Similar. B. Delayed. C. Weak. D. Opposite. Number 2, a hammer hits a nail with a downward force. What is the reaction force? A. The nail hitting the wood. B. Gravity pulling the hammer down. C. The nail pushing the hammer upward. Or D. The wood splitting. Number 3. Why do we move forward when we row a boat? A. Because the wind blows us. B. Because we push the water backward and the water pushes the boat forward. C. Because the paddle is sharp. Or D. Because the boat is light. Number 4. Forces in action-reaction pair always act on A. The same object. B. Two different objects. C. Only moving objects. Or D. Only heavy objects. Number 5. A rifle recoils or kicks back when fired. This is because A. The rifle pushes the bullet forward and the bullet pushes the rifle backward. B. The person holding it is shaky. C. Gravity pulls the gun back. Or D. The bullet is very heavy. And for 5 points, identify the action-reaction forces in the following picture. A man rowing a boat on water. And now let's check your answers. Number 1, the correct answer is D. Opposite. Number 2, the correct answer is C. The nail pushing the hammer upward. Number 3, correct answer is B. because we push the water backward. Number 4, correct answer is B, two different objects. Number 5, the rifle pushes the bullet forward and the bullet pushes the rifle backward. And for number 6 to 10, the action is the paddle pushes the water backward and the reaction is the water pushes the boat forward. See you next lesson. Remember, every time you take a step, thank the ground for pushing you back. See you in the next lesson. Thanks for your support. Please like and subscribe to Sir Dom's blog. Goodbye!